Welcome back, ladies and gentlemen. We were doing hypothesis testing. We want to continue with that. Here we have a problem, a situation. We have a nutritionist believes that Canadians consume, on average, so we're saying the average Canadian, consumes more than 2,500 calories per day. That's 2,500 calories per day. More than, right? He conducts a study and obtains a random sample of 50 Canadians. So he picks out 50 random Canadians based on detailed questionnaires and calorie counting. So he has these 50 people count their calories and do questionnaires. He finds that this group of participants, that's the 50 people, have an average calorie consumption of 2,750 calories per day. A previous study estimated that the daily calorie consumption for all Canadians had a standard deviation of 650 calories. Use the 0.02 significance level to test the claim that Canadians consume on average more than 2,500 calories per day. Okay, so let's do our hypothesis test. Step 1. We want to identify the null and alternative hypothesis. That's the first step. So H0 and H1. We're going to put colons after them. So we're going to be dealing with claims about the average, the population mean. Let me get rid of that. Now, what about the null hypothesis? The null hypothesis, that's H0, always involves the condition of equality. So we're going to put equal to. Now, what are you comparing the average to? Well, 2,500, right? If you read carefully, the claim that we're testing is Canadians consume, on average, more than 2,500 calories a day. So we're comparing the mean to 2,500. So for the null, always involves equality. You put mean equals 2,500. Now the claim that we're testing is that the average is more than 2,500. So since those keywords more than show up, we're going to use that for our alternative. Remember, the alternative does not involve equality. It would be either a less than, a greater than, or a not equal to. In this case, since it's the words more than show up, we're going to use greater than for our alternative. Now, this is actually the claim that's being tested, right? We're trying to test the claim, the nutritionist's claim, that the average is more than 2,500. Okay, so we have our null, we have our alternative hypothesis. Step 2. That is finding any critical values. So critical z-scores, critical t-scores, maybe just one, maybe two, we'll see. So first of all, are we doing a z test or a t test? Z or t? Question. Well, if you read carefully, you want to pay attention to the standard deviation. Is the standard deviation of a sample or is it of a population? So it says a previous study estimated that the daily calorie consumption for all Canadians, right? All Canadians, that's the entire population of Canadians, had a standard deviation of 650 calories. So that standard deviation there is sigma, right? 650. This is the population standard deviation. That's because it's for all Canadians, not just for that group of 50 Canadians, but this is for all Canadians. So because we have sigma, we're going to use a z distribution. So we're going to use the z distribution since sigma is known here. What else? How many tails? A left tail, a right tail, or two tails? Well, if you carefully read here the alternative hypothesis, it involves greater than. So when you have a greater than situation, you're going to use a right tail test. A right tail test, that's when you have a greater than situation. So to find our critical values, let's draw a picture of the, what's it called? Z distribution. Bell-shaped curve, right? 0 in the center. And we're looking on the right tail. So our significance level, if you read carefully what the significance level needs to be for this test, it says use the 2% significance level, right? 0.02. So that's going to be the area in the right tail. So the area in the right tail here, let me use a highlighter. Well, it should have been that color. Yep, yellow. That right tail there should be 0.02. That's called alpha, right? Alpha, 0.02. So 2% room for error here. 2% chance of making a mistake. So what we have to find is the Z upper star. Z upper star is going to be this number right here. Make it green. Where it's going to separate that yellow rejection region from the non-rejection region. Z upper star. And it just shifted on me, the screen shifted on me, okay. So how do I find Z upper star is the question. Well, I'm going to go into my Z table. I'm going to look up 0.02 in the middle of the table and then find the corresponding Z-score. Let's see what happens. So 0.02. So the closest number in your Z table to 0.02 is 0.0202. So that's 2%. Now let's find the corresponding Z-score. So if you go to the left, you're going to see you got negative 2.0 and over the top, and 0.5. So you got negative 2.05 as a Z-score. So let's think of that, negative 2.05 as a Z-score. Now negative 2.05 would fall somewhere like over here, right, as a negative Z-score. So what we have to do, we realize that ours is not negative, right? Ours is definitely positive, right? Ours is over here on the right side of 0, so it's positive. So we're just going to make it a positive 2.05. That's really important. Now the reason why when you look it up in the table, it gives you a negative value is because your Z tables always read from the left side. So they're going to give you a negative value. A negative value. So we have to just think to ourselves, okay, we want a positive value, right, because we're on the right tail. So we just flip the side. So that's really important. All right, so we have step 1 is done. We got the null and alternative hypothesis. Step 2 is done. We have the Z critical value, Z upper star in this case. Step 3. Come on. We're going to compute the test statistic value. Compute test statistic value. So we know we're dealing with Z's rather than T's. So the test statistic formula for a Z-score is X bar minus mu divided by sigma, the population standard deviation, divided by the square root of n. So we need to know what is n, what is X bar, what is sigma, and what is mu assumed to be here, for the sake of argument. Well, n is the sample size. If you go back and read the problem carefully, we took a sample of 50 Canadians, right? So we have n is 50. X bar is the average of the sample. What was the average calorie consumption for the group of 50 Canadians for the sample? He finds that this group of participants had an average calorie consumption of 2,750. So 2,750 is our sample mean. What was sigma, our population standard deviation? Well, we said earlier it was 650, right? 650, that's the standard deviation for all Canadians, 650. We're assuming that based on a previous study. And now the population mean, you're going to assume that is under the assumption that the null hypothesis is true. For the sake of argument, assume the null hypothesis is true. 2,500 is going to be mu here. 2,500, the population. So we'll plug these numbers in and calculate our z-score here, our test statistic value. We have 2,750 minus 2,500 divided by sigma 650. That's the wrong color. Divided by square root 50. So on top we're going to have 250 when you subtract. And on bottom, when you take, make sure you put parentheses around the bottom there. So when you simplify this, you put that in your calculator, 250, and then divided by parentheses, 650 divided by square root of 50, close parentheses. You're going to get 2.72, 2.72. So you want to round it to 2 decimal places. Always 2 decimal places when you're doing z-scores. When you do a computation, take the 2. So the next thing we want to do, we want to make a decision about the null hypothesis. Step 4. Make decision about the null hypothesis H0. Do we reject or do we fail to reject? Well, let's draw a picture. So I'm going to draw my z distribution. I have 0 in the center. I'm going to have a right tail situation. And we found that the critical, well, that'd be nice if that were solid. We had right here a critical z-score. It's going to be a z upper star here. That was, remember what that was? 2.05, right? 2.05. Come on. And we found that our z test statistic value, so the z test statistic value is 2.72. That represents your sample information. That's going to fall somewhere above, right? Above 2.05, that'll be somewhere here. That's a z-score above 2.05, right? It's to the right. Now, that purple z-score, 2.72, that is to the right. That is to the right of your critical value. So it's in the rejection region, right? The rejection region is in yellow, so we're going to reject. Reject the null hypothesis because we're in the rejection region. So the final step, step 5, it just has to do with wording our conclusion. Step 5. Summarize your conclusion. So write a conclusion summarizing. Okay, so what are we going to do? We're going to go to our wording sheet right here. So the question is, does the original claim, that's the claim we were testing, contain the condition of equality? No, it did not, right? If you remember, let's go back. Okay, the original claim was about greater than, right? The original claim was about greater than. Where was the claim we were testing? We were testing the claim right here. Shoot. Erase my stuff. We were testing the claim right here. Right, that's the claim, that the mean is greater than 2,500. So that's the claim we were testing. So it did not involve equality, right? Does the original claim contain the condition of equality? No. Did we reject the null hypothesis? Yes, we just rejected the null hypothesis, right? We said we're going to reject H0. So the wording is going to be the sample data support the claim. And then we write the claim. So we're going to write here, scroll, the sample data support the claim that, what was the claim? You fill in the claim. So the psychologists claim that Canadians, on average, consume more than 2,500 calories each day. Yep. Now that is a full hypothesis test. This one is actually right-tailed, right? It's a right-tailed Z hypothesis test.